Hello and good day, geometry. Today we will be talking about kicking off a new unit, Unit 5. And this unit is on similarity. Another word that kind of is associated with that is proportions. So whereas in Units 3 and 4, we focus a lot on triangles that are congruent, meaning they're the same size, same shape. In this unit, we're going to focus on triangles that are similar and polygons that are similar, meaning they are proportional. Okay, and we're going to start talking about ratios, which is a word you've probably heard before. A ratio basically compares a part of something to another part, right? It's different than a fraction, which compares a part to a whole. You know, like the fraction 3/4 is 3 out of 4. That 4 is your whole. A ratio compares a part to a part. And you can think about it, I guess, this thing, remember when we talked about the segment addition postulate, the angle addition postulate, that the two parts of a segment will add to the whole. The two parts of an angle will add to the whole measure of the angle. I just want you to remember here that a part plus the other part will equal the whole. Sometimes, usually in a ratio, there are only two parts, but sometimes there might be three, and we'll see that when we look for sides of triangles. Since there are, three sides to a triangle, we'll have three parts to the ratio. But the parts of the ratio all have to add up to the whole. So let's look at some examples here. Pretend the record of the Vikings this year was 12-4. What was the ratio of wins to losses? Well, we've got 12 wins compared to 4 losses. Okay, so our ratio is going to compare the wins to the losses. It's going to be 12-4. 12 wins, 4 losses. And if you look at the whole here, the total, well, how many games did they play in all? We can use the ratio to find that answer as well. 12 wins, 4 losses, total of 16 games played, 12 plus 4. Okay, we could simplify a ratio, and we simplify it similar to a fraction, to where we look for the greatest common factor, in this case 4, and we're going to divide each part by 4. And so our ratio in simplest form, if I ask you for that, is 3-1. Okay, basically means that for every 4 games that they played, they won 3 and they lost 1. All right. The next one, a recipe calls for 15 cups of flour and 35 cups of sugar. What is the ratio of flour to sugar? Ratios come up a lot in baking, right? And those of you that bake know, sometimes you want to double a recipe. Sometimes you want to only use half the recipe. When you double a recipe, you have to make sure that you are doubling every ingredient, right? Otherwise, something's going to taste funky, too sweet, too salty, or too bland, or whatever. Okay, so a recipe calls for 15 cups of flour and 35 cups of sugar. The ratio of flour to sugar, 15 cups of flour for every 35 cups of sugar. I don't know what you're baking that requires 35 cups of sugar, but I want it, right? So 15-35 is the ratio. We can simplify this, again, just like a fraction. Our greatest common factor of 15-35 is 5. So 15 divided by 5 is 3. 35 divided by 5 is 7. Basically meaning that for every 3 cups of flour we use, we'll be using 7 cups of sugar. Okay, that's the appropriate ratio for this recipe. All right. Moving on a little bit, let's see what else we have down below here. In this case, in a class of 27, the ratio of boys to girls is 2-1. Okay. Now the order here matters, right? Boys to girls is 2-1. That means that there are 2 boys for every 1 girl. And you might be asking yourself, well, that's only 3 people, right? 2 boys and 1 girl is 3 people. There's a class of 27. How does this work? How many boys and girls and how many boys and how many girls are in the class? Okay, so recognizing that the ratio 2-1 is only talking about 3 people, that's kind of important. Okay, because what we have here is a ratio that's already been simplified. So what we have to think here is, 2 to 1, that's 3 people. I need to get to 27 people, which means I need to multiply 3 by 9 to get to 27 people. And if I need to multiply the whole 3 by 9 to get to 27, I also have to multiply both the boys and the girls by 9. And that gives me a ratio of 18 to 9. 18 boys and 9 girls. Basically, there's twice as many boys as there are girls. That's what the ratio 2 to 1 tells us, as does the ratio 18 to 9. Okay, 18 is twice of 9. And then 18 plus 9, 27 people. The part and the part equals the whole. In a pet store, there are a total of 60 dogs and cats in a ratio of 13 to 7. Again, the order matters here. Dogs and cats in a ratio of 13 to 7. That means there are 13 dogs and 7 cats. Okay, so we can put our ratio here. We see this only represents 20 animals, which means this ratio has already been simplified. So to get from 20 to our whole, which is 60, we need to triple it. Multiply by 3. And because we multiply our whole by 3, we must also multiply each part. And that brings us up to 60 animals. 13 times 3 is 39. 7 times 3 is 21. 39 plus 21 equals 60. Our part plus our part equals the whole. That's good. And it's in the ratio of 13 to 7. Okay, so ratios can be simplified, but you can also take a ratio that's already been simplified and get back to the original to meet the context of the question. The third one here, in a bag of 150 marbles, so I'm going to recognize that as being my whole right off the bat. That's how many marbles we have in all. The ratio of red, blue, and white is 6 to 11 to 8. So here's an example of where we have a 3-part ratio, right? We've got 3 things that are all included in this bag. The order matters here. 6 red, 11 blue, 8 white. And the question is, how many red, blue, and white marbles are in the bag? Well, it probably doesn't take you too long to realize that 6, 11, and 8 do not make 150 marbles. Okay, that's only 25 marbles. So again, this ratio has already been simplified. To get back to the original whole, the original values here, to get from 25 to 150, we need to multiply by 6, which means we need to multiply all 3 of our parts by 6 as well. And that gives us, whoops, I almost wrote 66. That's the next one there. 36 to 66 to 48. And 36 plus 66 plus 48 brings us to 150. So 36 red, 66 blue, 48 white, all in the ratio of 6 to 11 to 8. Basically meaning, for every 25 marbles that we have, 6 are red, 11 are blue, and 8 are white. So if we wanted to add 25 more marbles for a total of 175, keeping these ratios the same, we would need to add 6 red, 11 blue, and 8 white. Okay. I think on the second page now is where we actually get to, here we go. Here's the geometry. Here's the triangles. So the ratio of angles in a triangle is 28 to 19 to 43. What are the angle measures of the triangle? What's missing here is a whole, right? In the last one, we had 150 marbles, or 60 dogs and cats, or 27 people. Here, we were just given the ratio. But since we're finding angle measures of the triangle, we already know what the whole has to be. In fact, what the whole is going to be every single time, right? There are always 180 degrees in a triangle. So our 3 angles, being in a ratio of 28 to 19 to 43, those don't add up to 180. So you got 47. No, that's not right. Yeah, 47, 90. Okay? We're halfway there. Living on a prayer. So to get to our 180, we've got to double the 90, multiply by 2, which means that multiply by 2, multiply by 2, multiply by 2. The actual angle measures in the triangle are not 28, 19, and 43, because that only adds up to 90. The actual measures of the triangle are 56, 38, and 86, which all add up to be our whole of 180. So here's the geometry application here, that similarity, that proportional relationship. Ratios are a big part of that. Okay. The ratio of angles in a triangle is 3 to 6 to 11. What are the angle measures of the triangle? So same situation here, okay, where we're talking about 3 angles. So the angle measures of a triangle, we know our whole is 180. We also know that 3, 6, and 11 don't add to be 180. So this ratio has been simplified. These add to be 20. And so we have to multiply by 9. To get to the actual angle measures. 27, 54, and 99. Okay, and all the relationships in the original or the simplified ratio should still exist in the contextual, the actual. What's the actual angle measures of the triangle? Right. We see, for example, that one angle is double the other one, 6 to 3. Same thing here, right? 54 is double 27. So all of those mathematical relationships should still exist. And of course, that brings us to 180. Okay. Let's look at the next 2. I think this is all we have, just 2 more. Okay. A triangle's perimeter is 72, and its sides are in a ratio of 1 to 4 to 4. What are the lengths of its sides? So we're no longer talking about angles now. So that 180 is out the window. We are talking about the triangle sides. And because triangles don't always have, a certain sum of sides like they do with angles, always 180, we're back to being given our whole here, right? Because we're talking about side lengths, so we have to be told what the whole is. 1 to 4 to 4 does not equal 72, it equals 9. And it doesn't say what units this is in, so let's call it 9 units. Okay. And to get to our whole of 72, which is the actual triangle, we need to multiply by 8. And again, these relationships should stay the same. I've got 2 sides that are the same in my simplified ratio. I've got 2 sides that are the same in my actual measurements. And 8 plus 32 plus 32 does equal 72, which is the given whole. And so we're good to go. All about scale factor, right? That proportional relationship. The ratio of a triangle's angles and sides is 8 to 11 to 11. Its perimeter is 570. What are the measures of its angles and the lengths of its sides? Okay, so both the angles and the sides actually have the same ratio here, but we're going to treat them differently because they have different holes. We have the sides and we have the angles. Okay, our sides, our whole is 570, being the perimeter. So we have 8 to 11 to 11. That gives us 30. Okay. To get to 570, we have to multiply by 19, I believe. Eight times 19 is 162. 11 times 19, 201. And 201. Uh-oh.
Teachers, if you have things like Catholic United Financial raffle tickets or a time card, could you please have a student bring those down to the office? Thank you.
Ooh, I get my time card in. So I did that math mentally, and I'm looking at it now, and I know that I'm incorrect. Why? Well, 162 plus 201 plus 201 does not equal 570. So then I go back and I say, okay, 8 times 19, 8 times 20 is going to be 160. So I think this should be 152, right? Because one less, oh no, my board's going to restart because it's mad at me. Right, it's 1 less 8. 8 times 20 is 160. Take away an 8, can only have 19, that's 152. Still not going to get to 570 there. So 11 times 19, well, 11 times 20 is 220. Take away an 11, that's going to be 209. And this is going to look better. Okay, 152 plus 209 plus 209 does give us 570. So check your work. It does matter. For the angles, our hole is 180, right? 180 degrees here. So again, with 8 to 11 to 11, that gives us 30. To get to 180, we're multiplying by 6. So 8 times 6 is 48. 11 times 6 is 66. 11 times 6 is 66. Check my work briefly there, quickly. Looks good. That equals 180. All right. So your assignments for, I'll give you till the end of the weekend, till Sunday evening, is going to be a Google Classroom quiz just on ratios and applying the scale factor to the ratios like we did today. Okay. That's all I've got for you. So have a tremendous weekend. Hop on over to Google Classroom and complete the quiz. And we will have live classes next week, Monday or Wednesday. You can come to either one, Monday or Wednesday, and then a recorded lesson again on Thursday. Have a great day, folks. That's How You Math. Talk to you later.